Okay guys, so in this video we'll be taking a look at expanding single brackets involving surds. So this is episode 3 of the AS Pure Maths series, okay, for those of you in year 12, okay, and even year 13 maths, and it's also appropriate for GCSE students as well. As ever guys, please feel free to pause the video, try and attempt any questions yourself, and then come back, press play, and feel free to take any notes for any questions that you weren't sure how to do. So it says here, question 13, expand each of the following, simplify if possible. Part A, so do root 2 times root 3. Now root 2 times root 3 is root 6. Okay, 2 times 3 is 6, and I can write it under a 1 single square root. Root 2 times positive 5 is positive 2 root 5. So your answer to that question is root 6 plus 2 root 5. Okay, and that can't be simplified any further. Part B, I have root 3 times root 5, which is going to be root 15. Okay, 3 times 5 is 15, and then I can put it under the same square root. Okay, root 3 times root 2 is root 6, guys. So it's root 15 plus root 6. Okay, and that too can't be simplified. Okay, part C, root 6 times 2 is 2 root 6. And root 6 times negative root 3 is minus root 18, because a positive times a negative is a negative, so I get that. Okay, now I can simplify root 18, and I know I haven't covered this yet, okay, but simplifying surds is all to do with finding the highest square number common factor that goes into that number. So root 18 is root 9 times root 2, which is 3 times root 2, because the square root of 9 gives us 3. So 3 times root 2, which is just 3 root 2 we write, okay, without the time sign. Okay, so I can now change this minus root 18 into minus 3 root 2. Okay, so this is what I mean by simplifying surds. Okay, you are trying to look for, okay, the highest square number that goes into that number that is a factor. Okay, so it requires you to have knowledge of your square numbers. Okay, next one, guys. I have root 10 times 5, which is 5 root 10. And then I have root 10 times root 10, which is the square root of 100, okay, which simplifies to 10. Okay, 10 times 10 is 100. The square root of 100 gives us 10. Okay, so a little trick there, guys, yeah, and a little sub rule, that if I have root x times root x, it always gives me the value of x, okay? So anything times itself will always get rid of the surd, essentially, okay? Part E, root 2 times root 18, well, that's root 36. 36 is a square number, which goes to 6. Root 2 times negative root 2, well, 2 times 2 is 4. The square root of 4 is 2, so it's 6 minus 2, which is 4, guys, okay? So hopefully it's making sense what I'm saying so far, okay? Part F, I've got root 5 times 3 root 2, so that goes to 3 root 10. Okay, root 5 times root 2 is root 10, and then we keep that 3 outside as a scale multiplier. Root 5 times negative root 5 is minus root 25, which goes to 5. Okay, part G, I've got 2 root 3 times 3 root 2. Well, I do 2 times 3, which is 6, and then root 3 times root 2, which is going to be root 6. So it's going to be 6 root 6, guys, for that one. And then here, I'm going to have a plus. Well, root 3 times root 3 is root 9. The square root of 9 is 3. And then I times it by that 2, so it becomes plus 18. Okay, so root 3 times root 3 is root 9. Root 9 simplifies to 3 because 9 is a square number. And then I've just times it by that 2 because I've got that multiplier of the 2 at the front. Okay, next one, guys. 4 root 11 times 5 root 22. Sorry, 5 root 2, sorry. 4 times 5 is 20. And root 11 times root 2 is root 22, guys. Okay, 4 root 11 times 2 root 11, that's going to give us an integer as an answer. 4 times 2 is 8. Root 11 times root 11 simplifies to 11 because it goes to root 121, and 121 is a square number which simplifies to 11. So I have 8 times 11, which goes to 88. Okay, next one, I've got root 27 times root 2. That goes to root 54. And then root 27 times root 3 goes to root 81 because 27 times 3 is 81. The square root of 81 we should know as 9. Now, root 54 does simplify as a surd. Root 54 is root 9 times root 6. Okay. And again, it's involving revision, knowing your factors of your numbers and knowing your square numbers. Okay, so 9 and 6 go into it. Okay, 9 is the biggest square number factor. Okay, that goes into 54. The square root of 9 is 3. 3 times root 6 is 3 root 6, guys. Okay, so root 54 simplifies to 3 root 6, guys. Okay. Last one, okay, for today's video, I've got root 12 times 7. That's going to be 7 root 12. And then I've got root 12 times negative root 3. Well, 12 times negative 3 is negative 36. So it's minus the square root of 36, which simplifies to 6. Okay, because 36 is a square number. So that's going to simplify to minus 6. Okay, and root 12 does simplify, so root 12 is root 4 times root 3. Okay, so the square root of 4 times the square root of 3. Root 4 simplifies to 2, okay, because 4 is a square number, so it's 2 root 3. Okay, and then reintroducing that 7 at the front. So I'm going to have 7 lots of 2 root 3. So it goes to 14 root 3. Okay. Because I have 7 lots of root 12. Okay. And root 12 simplifies to 2 root 3. So if I reintroduce that 7 at the beginning, which I had, okay, it becomes 7 lots of 2 root 3, which goes to 14 root 3. Okay, minus 6. Okay, right guys, that's the end of today's short video on expanding brackets with surds. I sincerely hope you found it useful. I hope you found it informative. If you did, please press like, please subscribe to the channel if you're new, and lastly, please click that bell icon, okay, so you don't miss out on further videos and further uploads. Okay, but that's it from me today, guys. Thank you so much for watching. Take care, stay safe, and I'll see you for the next one. Okay, bye for now.